Good morning, students. In this video, we are going to learn about an important application of kinematics, that is projectile motion. And before that, we enter into the topic, we should know about some interesting factors regarding projectile motion. What is projectile motion? If you want to know the understanding of projectile motion, you should know about interesting stories of scientists, some few scientists like Aristotle and Galileo. Why, sir, you chosen these two scientists regarding this topic? Because the great scientist Archimedes gave number of principles, particularly buoyancy force. If you want to weigh any object weight, you just put into the water and how much of water is displaced, that we can be able to measure that much of weight is the object. It is given by the Archimedes. At the same time, he gave one more fabulous, interesting formula and concept as a simple lever. If you are supposed to pull an object, a heavy object, only by the human power, you just easily move the object using some fulcrum, that is a simple lever. F1 by F2 is equal to d2 by d1. That is a mechanical advantages. Okay, if you want to suppose to move the object with the fulcrum, the object will move somewhat velocity in some direction. Am I right? Right. Okay. In this scenario, once Archimedes used to travel the ship, he just threw the object into the water. Instantly, we seems Archimedes going to find the weight of the stone which is immersed in the water. No. In this scenario, in this scene, Archimedes is going to find the motion of the object. In which direction the particle, the object or the projectile will travel. It's a very interesting one. Someone throw the object, it will be travel in somewhat direction. Actually, I used to throw this object like in this direction. But the object it does not travel the same direction. In somewhat time, it will be changed the direction. Am I right? Yeah. The same doubt has also developed in Archimedes. He tried to resolve the solution, but unfortunately, he can't able to do that time. On that time, the great scientist Galileo entered and resolved the problems. He suggested how to find the motion and how to find the direction of the object, and it is also named like a projectile motion. So today we are going to know about projectile motion. Projectile motion. In our previous classes, we learnt about the kinematics. What is the meaning of kinematics? It gives the relationship between distance with respect to time, displacement with respect to time, that is velocity and acceleration. What are all the relationship between these two factors? Okay, by using the kinematics, that's why I told you before, this is a very important one of the application of kinematics. So by using the kinematic equation, I am going to resolve and get the solution of projectile motion. Not myself, Galileo. That's why the father of kinematics is Galileo. Okay, students, let me discuss what is projectile. Sir, if you want to, or if you supposed to throw the object in with the initial velocity in air medium, the object or the projectile will allow the influence of under the gravity alone. This type of motion is called projectile motion. Listen, student. Once you throw the object with initial velocity, it will be travel in the air medium. The particle influences only by the gravitational force. This type of motion is called projectile motion, and the path followed by the particle is called trajectory. Very important one. That is the path of the projectile. Okay, sir. Shall we give some example regarding the projectile motion? There is a plenty number of examples available. Recently, you are watching IPL matches in cricket. Particularly, the batsman's score will be shown in like a wagon wheel. How much of score and then what are the scores are get from the area. So immediately the graphical zone will be open. That is a wagon wheel. The batsman score, he scored in sixes, in fours and twos. So every motion of the batsman's ball will go in the motion of like this. So this is a very important example of projectile motion. And then one more is a javelin thrown by the athlete. So he just give the initial velocity like in the x direction, that is the horizontal direction, but it will be travel in somewhat direction. And then one more, you are oftenly doing, if you are supposed to travel by car and by bus or by train, you are just throwing the object through the window. These are all the example for the projectile motion. So let me come to the point and let me find, sir, there are two types of velocities combined to make the effective motion like a projectile. So first one is uniform horizontal velocity. Uniform horizontal velocity without changing. And the second one is uniform vertical velocity by varying. So these two velocities combine to make the effective motion of projectile motion. Sir, and before that we have to remind the situation or atmospheric situations. So if you are supposed to throw the ball in an air medium, sir, there is certain resistance force offered by the air, sir. So you should neglect that one. In a projectile motion, you can neglect the air resistance. And the second one, sir, earth is revolving around the sun, sir. So can we consider the motion of the earth? So you can, no, here you can neglect that one also. So these two factors I am going to use and diagnose the problem of projectile motion. Next, what are the types of projectile motion? Now let me see here three diagrams. First one is I am going to throw the object from my position. I am going to just give the force to the upward direction, that is upthrust force. The object is going to upwards and getting by myself. So the point will be ejected at the same point and received at the same point. There is no displacement, there is no distance covered. So there is no projectile motion is occurred. And then second one shows some of the height, the ball is pushed to somewhat velocity, that is the initial velocity. So the ball will be traveled like in the direction, so like in the motion. This type of projectile motion is called horizontal projectile motion. And then third one, now I am going to throw an object in somewhat angle. Nowadays so rain is happen. So some waters are lacking in some flows. Some of the boys and girls are just passing the water. He just thrown the stone like in the form of inclined motion. So the stone will be just up and down like in the form of projectile motion. That should be called as an angular projection. So you just throw the object in somewhat angle. So this type of projectile motion is called angular projectile motion. Angular projectile motion. angular projectile motion. So let me discuss one by one. And before that, we should know the terms and we should know the basic phenomena of linear motions. In horizontal direction, an horizontal direction or the projectile motion, when a particle is thrown in the horizontal direction, so the motion is classified into two types. One is horizontal direction, and then one more is vertical direction. Okay, students. Now, what is the force in the horizontal direction? There is no net force acting on the horizontal direction. So, F, that is the net force, becomes 0. When the net force becomes 0, the velocity of the horizontal direction becomes constant. Very important, students. Listen here. When the net force becomes 0, the velocity becomes constant. When the velocity constant, the acceleration becomes 0. If you differentiate any constant value, you will get 0. So the acceleration is defined by rate of change of velocity. Here the velocity is a constant one, so you will get the acceleration is 0. And the next one is the vertical direction of motion. I am just going to throw the object in vertical direction. So the forces will be varying. Am I right? The forces will be varying. When the height increases or decreases, depends upon the gravity, so it will be attracting. So velocity will be varying. That means it is downwards direction. That is 10 meter per second. Once the velocity varying, acceleration also varying in downwards direction, 10 meter per second square, that is 9.8 meter per second square. Otherwise, I am going to take the round value. So these are all the basic terms, basic information to get the solution of projectile motion. So students, listen. In this projectile motion, we are going to find the path of projectile. First one, we are going to find path of projectile, that is trajectory. And then second one is velocity. And then third one is time of flight. And then fourth one is range. So by using the kinematic equation, by the mathematical simplification also, we are going to get how much of velocity is used to travel the object in somewhat distance. What is the time taken to reach the object in somewhat distance? These are all the phenomena we are going to found by using the projectile motion with the help of Galileo's experiment.